Good afternoon students. Today we will discuss about the remaining part of solution chapter and the points are colligative properties. In solution chapters we had discussed about solution, solute, solvent which forms the solution, properties of solute and solvent, then different types of solutions, then solubility, factors affecting solubility, solubility of solid in liquid solution, solubility of gas in liquid solution, various laws associated with the solubility, Henry's law, Raoult's law, Dalton's law, and at last we had discussed about the vapor pressure. Now we will move on to the next part of solution chapter, that is colligative properties. Colligative properties of non-electrolyte solutions. Basically, what are colligative properties? Colligative properties are the physical properties of the solution, and these properties depend upon the number of solute particles in the solution and not on the nature of the solute particles. Basically, they depend upon the number of solute particles. So, all such properties which depend upon the number of solute particles are called as colligative properties. And the properties that we are going to discuss in this chapter are vapor pressure lowering, boiling point elevation, freezing point depression, osmotic pressure. And one thing you should note down that while calculating the colligative properties of a non-electrolyte solution, the concentration of the solution is considered to be 0.2 molar or less than 0.2 molar. From this you can check that the concentration of the solute in solution is very less. That is, the amount of solvent will be more and the amount of solute will be less in the solution. This point is very important when we will calculate the formula for the lowering of vapor pressure. There this point will be very beneficial to us. Now we will move on to the first colligative property, that is vapor pressure lowering. Now here the vapor pressure lowering, as in this point, deals with the decrease in the vapor pressure. Now why vapor pressure decreases? Before this thing we should know about what is a vapor pressure. Now there is a diagram here and you can observe this diagram here. Now in this beaker pure solvent is taken, and this solvent, it is a pure volatile solvent. Now the volatile solvent, it is kept in a beaker and it is sealed. Due to the external temperature, the solvent which is taken in the beaker, it will vaporize first and it will convert into gas phase. We know very well about the gas, that gas particles can rotate or they can move from one place to another place. Thus, the gas molecules, they travel again towards the liquid, and the gas molecules travel towards the liquid again and condense to again form the liquid. So thus in the beaker itself two process takes place, that is vaporization and another one is condensation. So vaporization and condensation takes place simultaneously. Initially the molecules which are on the surface of the pure liquid, you can observe it here. So all the molecules on the surface, they convert into gas, and as the number of liquid molecules it is large, so rate of vaporization initially will be high and rate of condensation will be low. But as the time progress, the amount of vapor in the beaker will also increase, and thus the rate of vaporization and condensation slowly both the process take place at near about same rate, and when this happens, that when vaporization and condensation both work or takes place at the same rate, we say that equilibrium is achieved. And at equilibrium, the amount of gas present here and the amount of liquid present in the beaker there, both will remain constant. The number of molecules in gas form and number of molecules in liquid form, both will remain same. There will be no change in their number, it will remain constant. And at this stage, we calculate the vapor pressure. So at equilibrium, the pressure applied by the vapors above the liquid surface. So what is a vapor pressure? When a liquid in a closed container is in equilibrium with its vapor, the pressure exerted by the vapor on the liquid is called its vapor pressure. So vapor pressure is the pressure applied by the vapors on the liquid surface when equilibrium is achieved. Now the case that we are observing here, in this beaker there is only one type of liquid, and the liquid is volatile liquid. Now suppose in this liquid we have added non-volatile and non-ionizable solid, and if it is dissolved in it, then you can check in next figure here, the dash are the solvent molecules and the rounded particles are the particles of the non-volatile solute. Now non-volatile substance means what? The substance which will not evaporate at room temperature, so it will remain as it is. So the beaker that we have now in second case with non-volatile solute, if this is kept in the lab at room temperature, what will happen? Now you can observe it at the surface here, the number of solvent molecules and the number of solute molecules are also observed on the surface. So here along with the solvent molecules, the solute particles are also present on the surface. In case number 1, in beaker number 1, we had only one type of particle, that was the solvent particles, and all the particles were getting evaporated. But in case number 2, only the solvent molecules will get evaporated, but the solute particles will not get evaporated. This means the number of molecules getting evaporated or vaporized will be less, and as the number of molecules which are getting vaporized will be less, the vapors which will form at the top will also be less. As vapor will be less, thus the vapor pressure applied by the gas will also be less. Thus as non-volatile solute is added in the pure solvent which is volatile, due to addition of non-volatile solute to the solvent, the vapor pressure of the solution decreases.